Put your hand down. You smiling?
Yes.
Yes, sir.
Yes, sir.
Why are you smiling?
Because I love football. Football's fun.
Fun, sir.
Fun, sir.
It's fun.
Yes.
You sure?
I think
Now
so.
you thinking. First you smile, then you think. You think football is still fun?
Yes.
Sir.
Yes. No.
No?
Sir. Well, it was fun.
Not anymore, though, is it? Is it?
No, not by
No, it's not fun anymore.
No.
Not even a little bit.
No.
Make up your mind.
No.
Think. Since you're thinking, now go on. Think.
No,
Is
no.
it fun?
No, sir.
No.
No, sir.
Absolutely not?
Zero fun, sir.
All right. Listen.
All right, here we go. Hardy-Weinberg, the thing that we love to hate. When we talk about Hardy-Weinberg equilibrium, this is a way to measure the different alleles that we see in a various population. So when we talk about the different types of alleles, we know that in a population, we have to look at the same individuals, okay? Well, when we look at these individuals, we'll notice that some of them are dominant, some of them are recessive. So we give the big letter to the dominant, the lowercase letter to the recessive. These are our only options. There's no middle options. We can combine them. We're going to talk about that in a second, but we just have dominant and recessive alleles. So let's take a look at our dominant traits. If I want to look at a dominant trait, I'm going to give it a variable, and I'm going to give it the variable P. If I look at a recessive trait, I'm going to give it the variable Q. Instead of writing big A or little a, I'm writing P and Q. So if we assume that I add all of the P's and all the Q's together, that's going to be all of my alleles, just because that's all the dominant and recessive. That gives us our first equation. P plus Q equals 1, aka 100%. That's important. Write that down. We'll come back to it. Now let's look at how we combine all these dominant traits. Before, we got one from mom and one from dad, and we just wrote it big A, and we called that homozygous dominant. Now we're using P's. So this would be like PP, or in math, since we're doing math, we're going to call that P squared. Same thing for Q. Little a, or homozygous recessive would just be QQ normally, but now we're going to write it Q squared. What happens if you combine them? If you combine them, this would be like big A, little a, which would be heterozygous, aka PQ, and then we're going to put a 2 in front of it, so 2PQ. Now, once we have the understanding of these variables, if we add them all up, that's going to give me all the options. I can only have homozygous recessive, homozygous dominant, and heterozygous. So this brings us to our next equation. And this next equation, we just add them all up. If it equals 100%, we're golden. So let's take a look at it. Our second equation, this is the one that can be intimidating. Just don't let it intimidate you. Remember, we're using 1 to represent 100%. So if I take P squared, I add 2PQ, then I add Q squared, I should have all of the individuals. P squared, again, I'm adding all the dominant together. 2PQ, I'm adding in the heterozygous individuals. And then Q squared, I'm adding in all the homozygous recessive individuals. If I add all these up and they equal 100%, we know that we have a correct value. So pause the video and read this question. It's number 5 from your homework. Number 5 says that we have 28% individuals that are little r. Remember, that is Q squared. We're going to take the square root of that to give us Q. If we have Q and P, we can now plug it in. So we need to get P. We're going to take the value of Q squared, which would be 0.53. We did that by taking the square root of 0.28. We're going to use our math here. We're going to subtract 0.53, and we'll get a value for P as 0.47. Now we have both of our values for P and Q. Now let's plug and chug. You put your 0.47 squared. You add that to 2 times 0.47 times 0.53. Then you add that to 0.53 squared. If that equals 1, you're good. So I get 0.22 plus 0.49 plus 0.28, and I'm getting a value of 0.999 repeating, and that is close enough to get me to 1. Remember, don't overthink this. P squared, Q squared, 2PQ is just another way for writing little r, big R, big R, big R. Convert your ones into percentages. Just divide by 100 if you have trouble with that. you are good. So, to answer the question, how many are dominant? 70%. That's how many we see that is dominant. That is the math part. Now, Hardy and Weinberg, there are a few conditions. Imagine if you were to take a snapshot of the whitetail population in your backyard. It has to be a picture, meaning for this to work, there cannot be any deer moving in or out. There can be no natural selection occurring. You can't shoot one. There has to be a big enough population to tell the difference between these traits, and there has to be random mating. Does this normally happen in nature? No, it does not. That is a crash course in Hardy-Weinberg.
We're in a
Up
fight.
next, evolution.
You boys are doing all that you can do. Anybody can see that. Do your best. That's all anybody can ask for.